Alright, so here's our function stuff from chapter 1. So if you want to watch some of the videos, go back to chapter 1. I think some of these were around topic 7 when we start talking about functions. But you can look at the topics and see what pertains to what we're doing here. So function notation just simply says if f of x equals 2x minus 1, really all you're doing is thinking of it like this and plugging in 5 for x. So you're substituting the 5 in. So what you're going to do is do 2 times 5, because it's 2 times x, minus 1. That equals 10 minus 1 equals 9. So if you're looking for y equals that, y equals this, 9 is your answer. So again, this is function notation. This just means that I plug 5 in for my x. So g of x is x squared plus 1. G of 5 is 5 squared plus 1, which equals 25 plus 1, which equals 26. There's our final answer for those two. So for function notation, just substitute this value in for the variable everywhere in the equation. Alright, make an input-output table using the values 1, 2, 3, 4, and 5. So an f of x is, maybe I should do it a different direction. I don't think that's going to work as well. So I would say it's probably better to make an input-output table like this. Input are our x's. Our output is going to be the f of x's. And just to remind myself, that's 3x minus 5. So our inputs are 1, 2, 3, 4, 5. And so if x is 1, we have 3 times 1 plus 5, which equals 8. So our final input-output table looks like this. 1, input, output, 8. If we do 3 times 2 plus 5, that gives us 6 plus 5, which is 11. So 2, 11. Alright, and you continue the rest of them. You get 14, 17, and 20. So it's 3, 4, 5, 14, 17, and 20. There's our final input-output table. So this next one is going to be the domain and range. The domain are just the inputs, and then the range are the outputs. You notice all this stuff is in alphabetical order. X before Y, D before R, input before output. So the x's, the inputs, the domain are all the same thing. And then those get mapped to the y's, right, x to y, or the output, or the range. Alright, those are all synonymous. Those are the same types of things. So what we're going to look at here, the domain is all the x's, and that's going to be 2, 7, -9, -5. The range is going to be 3, 2, 9, -5. So it is a function because there's no domain value, there's no input that gets two range values. Basically, you recall, is it or is it not a function comes down to, can you draw one of these pictures? Can an input go to two outputs? This is our universal not a function if one input has two different outputs. So this is it a function? Yes, this is. Let's look at a couple more. Whoops, what did I do there? Do the following input-output tables represent functions? Alright, well, can we ever draw this? If we can draw a picture like this where our input is mapped to two outputs, then it's not a function. So we have three different inputs, three different outputs. That would look something like this. And so yes, this is a function. Here we have 1 and -2, and those are being mapped to 9, 7, 5. 1 goes to 9, -2 goes to 7, 1 goes to 5. So because of this here, that tells us that it's not a function. So no, that's not a function. Here we have all different x's. As long as you have all different x's, you know it's a function. we map it out, we get, we get 3, 8, negative 6. Should really go in descending order, but I'm just trying to quickly convey the idea. So 3 goes to 7, 8 goes to 7, and negative 6 goes to 4. So that's fine, right? Because every one of our inputs goes to only one output, right? 3 only goes to one thing, 8 only goes to one thing, negative 6 goes to only one thing. So yes, that is a function. Based on this discussion, it should be pretty clear that this is not a function. This is a function, and then this is not a function.